Okay, so following on from the previous video involving Kolmogorov's axioms, the corollaries, and the propositions that you derive from that. Let's say you're given the question, let A and B be events, and they want to prove that the probability of A intersection B is less than or equal to 1 minus the probability of A set difference B minus probability of B set difference A. Okay, so I'm going to go from the left hand side because I assume that's what most of you are going to do. Obviously, you can put it from the right hand side, and that is fine. So we're starting with probability of A and B. Immediately, you got to think to yourself, okay, what can I use from my corollaries, propositions, and axioms? What can I use? What do I know relates to A and B? So, because obviously we want to get something together so that we can manipulate it and prove the right hand side. Okay, well, immediately, obviously, it should jump out to you 3.6, which is inclusion exclusion for two events, and that's that the probability of A union B is the probability of A plus the probability of B minus the probability of A intersection B. Okay, so I'm just going to write out inclusion exclusion, and we can continue from there. Okay, so having done this now, so I'm gonna obviously I'm pretty sure that some of you know exactly what I'm gonna do next, but just so I leave no stone unturned, if you will, I just want to explain it, and so that I'm not doing things sort of ambiguously. So I look at the right hand side and I see that I've got A set difference B, and I've also got B set difference A. So I think, what am I going to use from this to get to there, right? So obviously I'm going to leave probability of A and B, because that's on the left hand side, so I ain't going to touch that. But let's look at A set difference B, right? Well, we know that that's where A occurs and B does not occur. Well, there's only one case for that, and that would be using A, because obviously using B, it wouldn't be the case. Using A union B, although you can use it, I guess intuitively just looking at it, you would use A. Oh, there is no one way to do this, by the way, because I made this example up. So you can go a million routes, and if there's a quicker route, obviously let me know. But yeah, I just made this up. This isn't one of his questions, but it is legit though. Don't worry. But yeah. So for A set difference B, I'm going to use probability of A, and for B set difference A, I'm going to use probability of B. And so geometrically, just to understand it, and so I can go on to the next point. Let's say we have two circles, because we have our two events. We got A, we got B, right? So A set difference B is just where A occurs, and B does not occur. So that's just going to be all of that, if you like, right? And so this is within A, which is fine. And then we've got A intersection B, which is just this. Right, and you see, so we've got A set difference B, A intersection B, and they don't intersect, and their union is A. So, hope you know where I'm going this. That means, obviously, we know by Kolmogorov's axioms, axiom 3, that obviously if AI intersection AJ is equal to the empty set, in this case it's A set difference B, plus, or AI is A set difference B, and AJ is A intersection B, is equal to the empty set, then the probability of the union, which I said was A, is just the probability of them two added up separately. So we can write that the probability of A, which is obviously the union, is equal to the probability of A set difference B plus the probability of A intersection B. And obviously I can do the same thing for B as well. Just by the same logic. Oh, I think the camera just shaking a bit. Sorry about that. So, okay. Plus probability of A intersection B, and then I've got the minus probability of A intersection B. Don't want to forget about that. Okay. So let's just simplify this. So I got I got two lots of A and B minus one lot of A and B. So I've got this. Okay, hopefully you're still with me so far. I should probably note. Okay, so yeah, so this is what I've used here is by Axiom 3, and you probably should state that somewhere. So I don't have too much space here, but if I just write here Axiom 3, well, hopefully that's supposed to be Axiom 3, but obviously in the exam do state what you're using to prove it, because you've got to prove it very, very carefully. That's what he's looking for. And obviously this formula here is 3.6. Okay, hopefully that's clear so far. Okay, so we've got our A set difference B, our B set difference A, and so we've got that here. Well, now we've got this 1 here, right? And well, if you've done a similar question to before, you know exactly which one it is. But obviously you got to look at your corollaries or propositions and see which one has a 1 in it, which obviously there's a couple, but also which one has the inequality sign, because obviously we've got to worry about this inequality sign as well, because we've still got equals, so we need to solve that. Well, if I look at my one of my corollaries, we note that by 3.3 that the probability of A is always less than or equal to 1, and obviously this is for any event A. That when I wrote this down, I said for any event A. Well, A union B is an event, and obviously that means that A union B by 3.3 is less than or equal to 1. And so since A union B is equal to this, this must be also less than or equal to 1. And so we have that the let's see, the probability of A set difference B plus probability of B set difference A plus probability of A intersection B is less than or equal to 1. Again, just to repeat that, we know that A union B is less than or equal to 1 by 3.3, because A union B is just an event. And so since A union B is equal to all of this, that means if this is less than or equal to 1, this also must be less than or equal to 1. And so we're almost there. You can definitely see it from here. We have that probability of A intersection B plus B intersection A plus A intersection B is less than or equal to 1. This is by 3.3. By 3.3. And so just taking it over to the other side and making A and B the subject, you have that the probability of A intersection B is less than or equal to 1 minus the probability of A set difference B minus the probability of B set difference A. And it's proven, and we write this little square box thing that I've never understood why. So hopefully that makes sense, and you understand that. Yeah, what he's looking for is to really prove it carefully, and you show that each step why you're doing it. It's really important that you state what you're using, and why you can use it, and that it works. And so that's the thing proven there. Obviously there's other ways to do it, and that's fine. If there's a quicker way, go ahead, do it. That's fine. I'm not saying this is the quickest way. This is just a way to prove it. And yeah, so hopefully you understand that, and that was clear. I would give another example, but I want to move on to chapter 4, which is sampling, and so there'll be lots of examples of sampling in there. So hopefully that was clear, and yeah, the next video we'll be going on to chapter 4, which is sampling.